Section 7.3, Problem 7, the last problem in this section. For this problem, carry at least 4 decimal digits through our calculations. In a random sample of 61 professional actors, it was found that 45 were extroverts. So let P represent the proportion of all actors who are extroverts. We want to find a point estimate, that's our P hat, for that proportion. So this is part A. So P hat, we have a formula for that. It's R over N, where R is the number we observe with a particular characteristic, being extrovert in this case, and N is the total number we're sampling. So this is going to be 45 over 61, and it says round our answer to 4 decimal places. So we're going to have to turn this to a decimal. I get 0.7377 and then a 0. So I'll just round off like that. So I'll report that over here on the left up by the problem. It says 0.7377. Now part B says get a 95% confidence interval for this P. All right, so 95% confidence interval. So let's go here. We have to get to the confidence intervals, and just to remind you, you're going to press Stat. You're going to go arrow over to Tests. Then you scroll down to item A. Now be careful, the first 6 say tests. We don't want a test. That's a hypothesis test. Next chapter. We want intervals. So intervals just happens to be under the heading of tests. So all the way down to A. A says 1 prop Z interval. 1 proportion Z interval. So we have to put in some numbers. What is our X? Well, the X is the number we observe with the characteristic. We're using R for that. So how many did we observe with that characteristic? 45. N's the sample size. 61. Sea level? 95%? Yeah, 95%. So 0.95 or 95. Calculate. Now here's what I come up with. I'm coming up with this interval. 0.62732 to 84809. Now let's see where we're going to round. What's it say here? Round to 2 decimal places, just 2 decimal places. So how about 0.6, I'm thinking 3, 0.63. So I'll put that as my lower limit. And the upper limit, 2 decimal places. So let's round up to 0.85. So this will be a 0.85. So our interval is really going from 0.63 up to 0.85, right? And we are 95% sure that we've captured the true proportion in that interval. And that just happens to be what the next question is. Give a brief interpretation. All right, forget this 5%. So we're at 95%. What's the first one say? We're 95% confident that the true proportion falls in this interval. Yeah, and the other one is outside, so forget that. So we're here at the second one. And the last part, C, do you think the conditions NP greater than 5, NQ are satisfied in this problem? Well, let's test it. Well, what is NP and NQ? Well, N is 61. And P, the observed proportion, is all right, that was all the way back at the very beginning. That was 0.7377. All right, so that's going to be 0.7377. NQ is going to be 61. Now, what is Q? Well, Q is 1 minus 0.7377. We'll just have the calculator do it. So let's take care of this one over here, NP. When I multiply these together, I get 44.999, all right, which is greater than 5, all right, so that one's okay. And 61 times, I just put it in like this, 61 parentheses, 1 minus 0.7377, close, and I got 16.003, which again is greater than 5. All right, so they are satisfied, but we have to come up with an explanation. You know, when we found this confidence interval up here, we used the z distribution, right? What did we use over here? We went to a z interval. So that's a normal. That's a normal distribution. Now, the only way we can use a normal distribution in proportions is if n times p greater than 5, n times q greater than 5. So do you think the conditions are satisfied? Yes. Explain why this would be an important consideration. Well, it's important because it allows us to use the normal distribution. Let's read over these. So it's going to be a yes. So I can get rid of that no, get rid of that no. So what's the first yes? Yes, it's important. The conditions are satisfied. This is important because it allows us to say p hat is approximately normal. There we go. That's what we want. What was the last one? Important because it allows us to say p hat is approximately normal. Oh, this one says binomial. I don't want binomial. I didn't read it. I just assumed it said normal. This is the one we want, right? It's important because it allows us to say p hat is approximately normal, not binomial. There we go. Good thing I read them all.